to your neighbor real quick. Talk to your neighbor. Read. I'm listening. Hudson. Your phone is not your friend. Put that away. That helps? It's like zoomed in, blurry.
In other words, somewhere between the rectangles and the area somewhere between this rectangle over its area under its area of the
All right, let me summarize what's happening. Eyes on the board. If I give you the area under the curve, there must be a point between these 2 points where I can go ahead and stop at to make these two areas to be equivalent. Okay? And that area is denoted by the following. Area under the curve is the integral. Area of the rectangle is the height times the width, just like the Riemann sums. So make sure you have this down, because we're going to apply the equation on the left and the right for the next problem. Everyone good with that? Okay? And it makes sense. If I put it up here, to be too big. Down here is too little, just like the left and the right Riemann sum. So moving on. Number 1, Ruby, let's read.
Find the value of C guaranteed by the mean value theorem for integrals for f of x equals 9 over x cubed over the interval 1 to 3.
So let's mimic the formula that we wrote on the flashcard. So here's our AB, that's our interval. So we're starting from 1 to 3. And our equation for this one, I'm going to rewrite this since I have to integrate, and it's easier when I bring that to the top. 9x to the negative 3 dx is equal to, so I'm done with the left piece. On the right piece, it says, now plug in the c into my function. So when I do, I get 9 over c cubed. I think it's c cubed, yes. And then it says b minus a. My b is 3, a is 1. So all I did was I rewrote it with the mean value theorem for the integrals. So the next piece that I'm going to do is just my left side. So here's my focus. I need all my work for this side right here first, and then we'll incorporate the right side. So if I were to integrate this, we get 9 over negative 2 times x to the power of negative 2. What am I supposed to have after? But because we're looking at definite integrals, and we're taking the top minus the bottom, do I need that plus c? Nope. You can write the plus c if you want. It'll create more work. That's fine. 3 to 1 or 1 to 3. Now let's plug it in. Anywhere I see an x, I am going to plug in what number? The 3. So we get 9 over negative 2 times the 3 to the negative half, or negative 2, I mean, minus, and because of that negative, I have to distribute a lot of things. Now I'm going to plug in the 1. 9 over the negative 2 times the 1 to the negative 2. Let's see what would happen in this case. Would this and this cancel each other out? Because 3 to the negative 1, negative 2 is basically on the bottom 9. So I know that's going to cancel each other out. That's going to give me negative 1/2. The next piece. What would happen if I get to, on this one, I have negative 2. Ooh. Does that even matter? What is 1 to the power of negative 2? 1. It's like saying 1 over 1 squared. It's still 1, so that doesn't really matter. So if I rewrite this and I distribute my negative, we have 2 negatives. So we have plus 9 over 2. And if you have to do the tedious math on the side, go for it. Oh, 4. He's all proud. Negative 1 and 9 is 8. So now it says, we want to know when they are equivalent to, so let's rewrite this. My left side is simply 4. Let's copy the right side exactly as I see. Oh, actually, can I just put times 2? 3 minus 1. Okay? So when I divide it by 2 on both sides, we get 2 is equal to 9 over c squared. And to make the c on the other side, I'm going to move these two. Oh, did I write squared?
It's cubed.
Well, too late. I already noticed. I know. You're like, why didn't you just keep that mistake? So c cubed is equal to 9 over 2. And let's go ahead and cube root this. And I know it's not going to come out, which is fine. So when I cube root, we get c is equal to cube root of. Can I simplify 9 over 2 if we wanted? Isn't that basically 4.5? What if you wanted to leave it as 9 over 2? Will I give you full credit?
Yes.
Yep. Now, I want to make sure that number is relevant to what I'm looking for. I need to figure out, is this number that I found really between 1 and 3? So let's do some math real quick. What is cube root of 1? What is cube root of 1? 1. I'm going to send you back to another grade. I don't even know. What is cube root of 8? 2. So we know this number, 4.5, is between. So if 4.5 cube root is between 1 and 2, is that also between 1 and 3? Yes. Now that part was extra work to check. If you're good with it, you don't need to check any further. But I want you to look at the relevance of the numbers. All right. Yes, ma'am.
How do you get 2 by itself on, like, under the 4 equals? Where did you get 2?
2 came from 3 minus 1. All right, let's go on to the next piece. Y'all ready for the back?
I'm ready.
All right. We are ready. Last page. Okay, let's not worry about reading, but look at this right here. Oh, box average value. So let's look at what the average value or where it came from. So this is on the back. I'm going to summarize this for you guys. Isn't this basically the mean value theorem? So if I make f of c by itself, I need to divide it by b minus a. Is that true? So this became this. Is that true? That is your average value. So write this down. If you want to write the final piece, that's fine. But I think it's good to know where it came from. Hudson, are you going to write? Not today, huh? Maybe tomorrow? But then it's Friday tomorrow, so that's also not tomorrow.
Oh yeah.
Okay. No.
Why no more
Then make some. Give us a new poll after.
I don't want to make a poll.
Vote. Okay. So we'll do number 2 by hand because you'll need to do 1 by hand on the test. And we'll do 3 and 4 using the calculator. All right? So don't grab it yet in case you're tempted. Because we love our calculators and our phones. All right, Alan, let's read number 2. Find.
Find the average value for f of x equals 3x squared minus 2x on an interval 1 to 4, and all the values of x in the interval for which the function equals the average value.
All right, this piece right here we're going to do at the very end. Something is equal to something. So if you want to write the function given to us right now, 3x squared minus 2x is equal to something. And that piece is what we're going to find first. So let's go ahead and mimic the average value. So it says f of c is equal to 1 over b minus a. So in our case, which is our b minus a? 1 over 4 minus 1. That's given on the interval from 1 to 4. The function given is 3x squared minus 2x of the dx. Again, this is going to be done by hand. So let's go ahead and simplify. Isn't 1 over 4 minus 1 1/3? Yes. So I'm going to put a bracket because we're dividing by 3 at the very end. Let's integrate. If I integrate 3x squared, we get x cubed because 3 over 3 eliminates. If we integrate negative 2x, we get minus x squared because 2 over 2 eliminates. And then do I need plus c? Nope. And then I'm going to go ahead and find this number from 1 to 4. So I want to worry about this guy right here first. And then we'll divide it by 3 at the very end, if it is divisible. So we have 1/3. We plug in the 4 first. And I'm going to use my bracket. Kind of want to leave the 1/3 until the very end, but that would be mathematically incorrect. Minus, now we're going to plug in the 1. So another parentheses. So we have 1 cubed minus 1 squared. Let me make sure my parentheses are good. Which part is going to eliminate right off the bat? The ones. So we don't need any of that. So if I go ahead and further simplify, we get 4 cubed is 64. What is 4 squared? 16. Is it 48? Over how many? 3. And is that divisible still? 16. And that's our average value. So let's right here. This is my average value. So let's go back to what I underlined at the very beginning. The function 3x squared minus 2x is equal to the average value that we found, 16. So this is going back to algebra 1. We need to solve for what is my x. So I need to go ahead and set this equal to 0 because we are going to factor. So if you missed factoring, it's your happy day. Is this one doable as one go, or do we need to do grouping? Grouping. Do y'all need a reminder of grouping? Oh, man. That's okay. The grouping states we keep the first and the last one. And then I need to figure out, I'm going to write off to the side over here. Well, can I multiply? What is 3 times negative 16? So negative 48. And then negative 2. So what two numbers will satisfy the product of negative 48? But the sum of negative 2.
Negative 8 and 6.
Oh, y'all can do algebra 1. So we have negative 8x plus 6x. Now we are going to group them in pairs. What can come out of my first set?
3x.
Oh no.
Just X.
Somebody's so confident. Stop it. The next one, what's going to come out? 6 and 16, 2. So we have 3x minus 8. And the fact that my second parentheses are identical, that's always good. So x plus 2, 3x minus 8. And when you do solve for 0 for both of them, the first one is going to give us negative 2. Second one will give us 8 over 3. But we have to make sure that's within the bound. Which one is within the bound of 1 and 4?
8 over 3.
Done. So now get your calculator. If I assigned you one, go get it. Yes, ma'am? Let's see. I might have, if you told me. Oh, I never assigned you one. Do you want one for class set? Okay. So we got 11, 12. All right, Lily, you're permanently number 12. Allie and Camille, those calculator 89s, right?
Yes.
That needs to go to Capetta. After today, it needs to go to Capetta.
What? Sorry.
We don't use 89. I use 84s. So make sure you turn that back in. All right, let's go on to number 3. Gianta, let's read. Ryan is writing. Let's read, Gianza.
Oh, yeah. Ryan is writing this classical in for 0 is less than equal to t, which is less than or equal to 40 minutes. Ryan's velocity is measured by r of t plus t minus 5t squared plus 250, where t is measured in minutes and r of t is measured in meters per minute. Based on this model, find Ryan's average velocity during the first one, 0 is less than equal to t, which is less than equal to 1.
Let's underline average velocity. Our average velocity is for this one, it's going to be the average value. So average value. That looks like E squared G. Now, are any of you guys thinking, looking at that, does that sound like AROC possibly? Write something on the side. If it says, instead of average velocity, it says average acceleration, then it's AROC. So be really careful when you're looking at the phrases. Is it really asking for AROC or just average value by the formula? Okay? So if you can't differentiate that, your answer is completely wrong. So I'm going to bubble this off to the side to say, well, not really relevant. So let's go ahead and apply the average value. So we're looking at the formula right above. So we know 0 to 40, which is my A, which is my B? A, B. So let's go ahead and apply the formula. It says 1 over B minus A, 40 minus 0. The integral from 0 to 40 of the function given, t cubed minus 5t squared plus 250 dt. And ideally, we should have parentheses. And all you need to do literally is plug this into the calculator. So let's see where our integration is. I want you all to go to math. And when I go all the way down, which one has integration? 9. And if you're not sure, it's okay. It's going to give you the skeleton model. Oh, I forgot something. I should have 1 over 40 first. Alpha y equals, silly me, 1 over 40 minus 0. And then let's do math, 9. Should we write that on the top somewhere?
Yeah.
Let's write out math, number 9. Just remember the fraction on your own, though. Let's fill in what we know in our blanks provided. And we know our x's, no t's. Oh, no. I'm not good at plugging things in from the paper. Oh, x. And that's going to give us our average value of this. Is it a clean number? Clean fraction-ish? Yep. So we get 13,583 and 1/3. And that's going to be minute or meters per minute. Oh, very fast. Maybe that's how fast his mind is going. All right. Try converting that to feet. Is it faster or slower?
Faster. His feet are smaller.
Smaller? Oh, I'm so proud of you. All right. On number 4. Sam, let's read.
Riley is also riding her bike on a paved trail, but instead of function, gave the table values that show her velocity at different times during the minute. Based on this data, Sway Riley average velocity during the interval of 0 is greater to t 40 using RS with 4 equal sub-intervals.
So we have 4 equal subintervals. So let's go ahead and see where that's going to go. 0 to 10, 10 to 20, 20 to 30, 30 to 40. So the previous question gave us the equation. So we were able to figure that part out. But this one is given as a table, so we have to use what? The Riemann sum. All right. I'm going to put on here, here's my A to B. Let's go ahead and write out the average value from 0 to 40 is going to be 1 to 40 minus 0. And I'm going to use a bracket because I need to find out what is my Riemann sum since integral value is not given to us. So just by looking at this, we need trapezoid. So on our trapezoid, it says base 1 times base 2. The bases are the endpoints. So in this subinterval, we have base 1 and base 2. That's simply review from a week ago. Divided by 2. And what is our difference on the time per interval? 0 to 10? 10. And let's do the same thing for the next one. We get 1900 plus 10, 700 divided by 2 times 10. I'm not going to have enough room. Oh, goodness. Divided by 2 times 10. And I'm going to move on to the bottom. 32,700. Ooh. 73,900 divided by 2 times 10. Let's type that in. And the bracket is parentheses. Milo, are we doing this in our head? On the test too? You're like, no. Make sure you put 1 over 40 at the beginning or at the end. Ruby, how many?
824,000.
Ooh,
Is that wrong?
I got a different number, so I could be wrong. Did someone confirm 824,000? Did you divide it by 40?
Oh, you divided by 40.
Average value.
Well, that's what I did wrong in my quiz.
I know, don't do it again.
It's 20,600.
Oh, yeah. 20,600, and that's meters per minute. Do we have a back? Nope.